All right, S4H.3, largest empty circle problems. Okay, so first thing we're going to do is we're going to draw a Vorney diagram here. So I'm going to plot these points and label them. So we've got -3, 3, that's A, -3, -3, that's B, 1, 1, that's C, and 3, -1 is point D. Okay, so the first thing I'm going to do is between A and C, I'm going to figure out where the midpoint is. So I go down 2 over 1, 2, 3, 4. So if I go down 2 and over 4, I can go down 1 over 2. And you can kind of see that's kind of halfway between, right? Down 1 over 2, down 1 over 2. So that's my midpoint between A and C. And then I'm going to look at the slope between A and C. And it goes down 1 over 2. So my slope is -1/2. Okay, so now I need the perpendicular slope of AC. And to find the perpendicular slope, I take the opposite sign and the reciprocal. So the perpendicular slope is going to be 2. So from this point, I'm going to go up 1 over 2, up 1 over 2, and I can make my dotted line. I'm not making it very dark because I'm only going to use part of it. And now I'm going to find the boundary line between A and B. That's the easiest. So it just goes down 6. So halfway, it's at 3. Okay, and this equation here is y equals 0, right? Y equals 0 is this line, and where they intersect is where my vertex is going to be. So now I'm going to draw this a little more solid. Okay, so this is the line, the boundary between A and C, and the boundary between A and B. Okay, now let's figure out the boundary between C and D. Okay, so it goes down 2 over 2, so midpoint's going to be right there. Okay, and it looks like the slope is down 1 over 1, down 1 over 1. So the slope of CD is equal to -1. So the slope of the perpendicular for CD is going to be +1. The reciprocal of 1 is 1, right? And then we change the sign. So there's my boundary line between C and D. And let's get a boundary line between D and B. So this goes over 1, 2, 3, 4, 5, 6, and up 2. So I'm going to go over 1, 2, 3, and up 1. And that's my midpoint. It's halfway between B and D. So, and the slope between B and D is over 3, up 1. So it's going to be +1/3, right? Because it's going up. So the perpendicular slope of BD is going to be the opposite sign and the reciprocal. So it's going to be -3. So now, so from here I'm going to go down 3 over 1. Okay, so now I've got my line. And there's the vertex midpoint, and now I can draw those lines. So here's my boundary line between C and D. Here's the boundary line between B and D. And now I need to figure out the boundary line between B and C. So let's just look at parts of it just to see. See if you can, like this, you can see that pink line is definitely perpendicular between the dots C and D. If I look at just this part right here, you can see definitely between points B and D, that pink line is perpendicular. Okay, if I hold it this way, you can see that's perpendicular bisector from A to C. Anyways, okay, what's the midpoint between B and C? So it goes over 1, 2, 3, 4, and up 1, 2, 3, 4. So the midpoint's going to be over 2, up 2. There's my midpoint. It looks like the slope is 1, so the perpendicular slope is going to be -1. And you know you've done it right if this vertex intersects with that vertex. Okay? And you can also, with all Vorney diagrams, if I put the sharp point at the vertex and put the pencil at the dot, and to draw a circle around, it should go through the 3 points that are nearest to it. Oops. Oh. Okay, and as you can see, the way I've drawn the circle here, from the vertex, it should always go through the 3 points nearest it. So now here, this vertex should go through B, C, and D. If I draw it carefully, it will. So between B... So you can see this circle and you have better luck drawing the circles if you twirl the paper and keep this still, because otherwise the pencil kind of shifts around. So anyways, that's how you make your circles. Let's move on. So the concept of largest empty circle is that this space in between the circle, so the vertex is the furthest place away from any of these sites B, C, and D. And the bigger the space is, then the farther this vertex is away from any particular point. Okay, so in this example here, they said you got points A, B, and C, and D. Find the largest empty circle. So the first thing I did is from this vertex, I drew a circle that went from the vertex to point C. And if you draw the circle, you'll see that it goes through A, B, and C. And here, if I have the vertex where the boundary lines meet, and I put the sharp point there and the point at C, and I draw the circle, you'll see once again that goes through A, D, and C. Now this is kind of a nice example because my coloring is off here. Oops. Anyways, this is a nice example here because you can clearly see that the blue circle is larger than the yellow circle here. But even if I couldn't tell from looking at the circle, I can get the coordinates of the vertex. So the coordinates of this vertex is 0, 2. And I can take another point, which let's just say I take point A. Using point A is -2, 1. I can use the distance formula. So the difference between the x values, 0 minus, is that what we did here? So from here to here is 0 minus 2. Minus -2, it's okay. And then 2 minus, or 1 minus 2, and then we get our distance here. From here, we've got our vertex at 1, 0, and using this point, I could do the difference between 1 minus -2, in parentheses squared, and then 0 minus 1, put it in parentheses and squared. And so we end up with 3 squared plus negative 1 squared, and we get the distance after taking the square root. So this tells me that the radius of the blue circle is 3.16. This tells me the radius of the smaller yellow circle is 2.24. And so the center, this gives me the center and the radius. Hit pause if you need to look at this some more. Okay. Hit pause if you need to look at this part more too. So find the center and the radius of the largest empty circle. So the center is always where the vertex meets. Here it's at 1, 1. Using a point on the circle, I can use the distance formula and find. So once again, how does the distance formula work? I take the difference of the x values, and I take the difference of the y values, I take the difference of them, square it, and then add those squares together, and then take the square root. Hit pause if you need to look at this some more. Okay, next problem. You may want to hit pause to look at this definition. I'm going to read it out loud. So when drawing empty circles, the center of the vertex is always equal to the distance away from 3 sites. So because it is an equal distance away from the 3 sites, the circle will cross into the 3 cells. Therefore, it is impossible for the circle to lie in exclusively one cell. So a really good example is this last page here. Here I've made my circle, and notice the circle goes into cell A, it goes into cell B, and it goes into cell C. You're never going to have one of these circles exclusively inside a particular cell. It's always going to include multiple cells. Hit pause if you need this definition. Okay, next one. So I'll redo this here. So first of all, I'll just put this up here so you can see it, and hit pause if you need to copy it down. Okay. Hit pause if you need to copy this down. Okay, so let's do this one together. So you plot the points here, and let's just talk it through. No, let's not. Okay, A is negative 2, 7. B is 4, 7. Oops. C is 6, 3. And D is negative 2, negative 5. Okay, construct the Vorney diagram. Okay, so between A and B, halfway between there is this vertical line here. So it's across 6 spaces, so I'm going to go across 3 to draw my vertical line. Okay, between B and C, it goes down 4 over 2, so I go down 2 over 1. There's my midpoint. The slope is negative 2, so the perpendicular slope is going to be positive 1/2. And so I'm going to draw my dotted line. Okay, and they meet there. So now I've got my boundary line between A, and I got my boundary line between B and C. They're going to meet there. Okay, now let's find the boundary line between A and D. This is a vertical line. So, and the difference between here and here is 7 plus 5 is going to give me 12, so it's going to be 6 units away. So my dotted line goes through here. Okay, now the boundary line between D and C, if I go here, I go 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7, 8. So halfway in between is over at 4. Go over 4 and up 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and that's my midpoint between D and C. It looks like the slope is between here and here is 1, so my new slope is -1. Okay, and these lines meet right there. Now I can draw my boundary line, and this connects between there and there. And, okay, so what's last is the boundary line between A and C. This goes down 1, 2, 3, 4, and it goes over 1, 2, 3, 4, 5, 6, 7, 8. So it really goes down 2 and over 4, and that's the midpoint between A and C, and down 2 over 4. So my slope between A and C is -1/2, so the new slope is going to be -2 or +2, and connects right there. So okay, so if I use my compass and draw circles from there and from there, I will see from here the radius from here to here draws the blue circle. From here, the radius draws the orange circle. And just from looking at it, you can see that the blue circle is bigger. So if I know that the blue circle is bigger, I know the center of the blue circle is at 1, 0, and I pick a point at random. I'm going to pick C, 6, 3, and then I can plug it in the distance formula and find the radius. Hit pause to copy this down if you need to. Okay, last page. Hit pause if you need to copy and look at this. Okay, find the optimum position for Bridget's store. State how far the location is from the nearest competitor. So we've got sites here. We've got A, B, and C, and these lines were already drawn for you. And so the optimum position is the center of the largest empty circle. So we want to have the new store right here. It looks like the yellow circle is bigger, so let's see if that's true. We're going to have to do some calculations just to verify. So if I use V1 and then a point like A, I can use the distance formula, and I figure out that the radius of the blue circle is this. If I use V2, which is 2, 0, and a random point like A, which is on the yellow circle, difference of the x values, difference of the y values, I find that the radius is 6.32. So the optimal position of the vertex for the largest circle is going to be 2, 0, and the distance is 6.32. Now, question B says, just before she puts in the new site, a new burger store opens at 4, 2. Redraw the Vorney diagram with the new store added. So 4, 2 it gives me a new store right here. Okay, so now I have new boundary lines. Halfway between this and B is going to be right there, and then halfway between here and here, I'm going to have lines there. So so I've got new boundary lines. So I've got new vertices. I've got a new vertex there. I've got a vertex here, and I've got a vertex here and there. So anyways, so now that my biggest circle, which was this yellow one, has been broken up by having the new dot in there, the other circle, which wasn't the biggest, now is the biggest. So that's why the new optimal position is going to be here, because the burger store at 4, 2 is inside of what used to be the largest circle. And I hope that helps.